followed by this expression. And if you see, if you put this theta equal to 0, first of all let it be r. This is the radius of the circle and r is the distance in which we are looking for the stress concentrations. A is the area, radius, and r distance we are looking for, and this is the theta. Now this expression says when r equal to a, then this is 1, this is 1. So 1 plus 1 2 multiplied by 1 plus 3 4.
2
Here it
minus
is
2 cos theta, 1 minus cos
two will be
theta.
cancelled out. Sigma 0, sorry, sigma 0, sigma theta, tangential space equal to sigma 1 minus 2 cosine theta. Sigma 1 minus 2 cosine 2 theta. Here a equal to r. This is 1. This is also 1. 1 plus 1 2. Here it is 2. So this is cancelled out. It will be 1. Here 1 plus 3 4. So it will be 2. Sigma. So sigma theta tangential space divided by sigma equal to 1 minus 2 cosine theta. Now when theta equal to 0, cosine theta equal to 1. Then it is minus 1. Theta equal to 0 means here this is the theta equal to 0 here. This term is minus 1. Because tensile force you are applied away from the circle, it will be compressive. Very it is not straightforward idea. I will apply tensile load and here it will be compressive load. Minus means sigma theta by sigma equal to minus 1 means it is same value opposite side. I will apply tensile for sigma, it will show minus sigma here. But when theta equal to 90 degree, when theta equal to here 90 degree, 1 minus 2 cosine 2 theta. Cosine 2 theta will be cosine 2 theta. Cosine pi minus 1. So 1 minus 2 multiplied by minus 1. 1 plus 2 equal to 3. That is the stress concentration factor 3 for the circular road. Which location? Location is here. This address. And this formula is valid when this radius of the circle is very small compared with the dimension of this plate. We call infinite plate. But when we are changing this length and this width of the plate, we are reducing from the infinite to some finite. There will be some effect for the height and width. As load has been applied this direction, cross-sectional area which will resist the force, that is, this value will be subtracted. That means if it is axial load along the x directions, its length is not important for the area, but the area, this cross section is important. If thickness is same, then this width is important. Now when this value of the width is comparable with the radius of the circle, there will be some effect of the length. For kg, kg is the stress concentration. That will know what will be 3. That will be more than 3. That concept can be utilized here. So same figure, initially what I told, it was minus 1 here and it is 3, then it will vary like this. So it is minus 1 is here, then it will vary like this, then it is plus 3 here, it will vary like this. We will prove that. Now it is say for example we have two cases, theta equal to 0, theta equal to 90. This point and this point. Next is when we have this width is capital T, it is comparable, there will be some effect. And that effect has been shown here. I have given in the study material. So this variation will not be 3 in that case. It will be different. Now how this relationship varies? Say for example sigma nominal. Nominal means based on the current cross sections. So it was D was the width minus twice R. that ratio if you take here this ratio, and based on that ratio this nominal stress you can calculate. Then Kt will be sigma max by sigma nominal. It is showing less than 3 because nominal area was less, nominal stress was less. Once again I am telling, if you have infinite place, there is no effect of that with d. When we have length is, when the radius of the circle is comparable, or discontinuity is comparable with the width, there will be some factor. So nominal stress we can calculate, and Kt will be sigma maximum by nominal stress. That you have to calculate. Yes. Now with this assignment I have given, I have to open that. This one. First thing was sigma maximum equal to sigma a here, and that is Kt multiplied by sigma nominal. And sigma nominal is P by T thickness, and D, this D minus twice r. And that Kt is related to this expressions. This is analytical expressions, not so easy now to explain. Maybe for your MTech or PhD theory of elasticity we can prove this. Okay, that subject theory of elasticity. Uniaxial load, sigma maximum is related to this, and Kt is related to this. So what we'll do, we'll take some model, we'll apply some force like this and circular. Then sigma nominal will calculate. Then that nominal multiplied Kt will be sigma max. From finite element we will get sigma max by sigma nominal is Kt. This is the theoretical value to compare, and we have to say percentage of error. Single case, first case. Second case, instead of circular one, I have elliptical shape. I have the elliptical shape of the infinite plane. It is infinite plane, elliptical shape. And it is semi-minor axis is twice A, semi-major axis is twice B. So sigma A and sigma 1 and sigma 2 load we have applied. Now consider only one, sigma 2 is 0, only sigma 1. So sigma A equal to Kt multiplied by sigma, Kt equal to 1 plus 2A by B. When A equal to B, then Kt will be 3. We have shown before. Test concentration factor will be 3 for this case when it is circular hole. Now Kt sigma B, sigma at B here, it is minus sigma compression. Case 2. Case 3 is, let's say I have that elliptical hole, it is not infinite plane, it is finite width. Then similar way, sigma max equal to related to this expression, and Kt is related to this. And what is A and D? D is this distance, A is this distance. Load is applied these directions. Now C1, C2, C3 and C4 terms we calculated, provided A by B ratio less than 8. It is varying from 1 to 8. Now once I have C1, C2, C3 from this expression, I can calculate Kt. From the finite element I can have sigma max. Sigma nominal I can calculate on this theory. Then I can compare theoretical value to finite element value. Let's show that Excel sheet I have created. 3 cases. First case, that sigma max, this is the formula I have taken from this. And if I have E value, mu value, length value, this is the length, D value, R value, T value, pressure value, twice R by D, twice R by D value. Kt value theoretical is this. For this set, if I change this value, say pressure 10 MPa to 50 MPa to R by D value something else, then I can have this value. Then sigma nominal, I am utilizing this expression. Nominal stress. And K sigma maximum will be Kt multiplied by that value. Sigma maximum will be this. Now from the finite element, what will be the sigma maximum? Then I can get percentage of error for that particular problem for the circular. So here what I have shown infinite plane. If it is infinite plane, the relationship was like this. But this is for the finite plane. Case 1. Case 2. Single elliptical hole, infinite plane. So everything I put. And the expression of this, I have utilized that expression. And I have taken some a by b value. I want to compare with that. Number 3. So, little bit complicated expression is this. What I did, these are the inputs, and C1 value I can get from this. I used that expression. Simply I put, because this is the way aerospace engineers are calculating theoretical value of the stress of different components of the aircraft. This is the basic logic will be adopted in the industries. So C1 is this, C2 is this, C3, C4, and KT. Now if I know this KT and I know the sigma maximum, sigma nominal value I can calculate from this expression. Sigma nominal value. Then what will be the percentage of error based on this finite element analysis? This is the 3 problems are analogous. These 3 problems you have to do. Now let's open Ansys workbench and then we can start. First thing is, what type of analysis it is? 3D analysis, plane stress or plane strain, or axisymmetry. You have tell me this analysis can be classified as 3D analysis,
2D analysis.
very good. If it is 2D, it is plane stress, plane strain, or axisymmetry. 3 options are available: plane stress, plane strain, and axisymmetry. Which one you want to do? Very good. It is plane stress. Very good. So what we will do? First of all, we take geometry.
समझा देना ठीक है कैसे select.
So we have confirmed that it is plane stress problem. Let me save this. Save. Now you are attending carefully and you told perfectly that it is plane stress. Now to start with, by default Ansys will understand 3D world. So to make it
Properties.
2D, go to the geometry, property. Here from 3D analysis to you change to 2D. First thing you have to do, go to the geometry, then right click property, you make 3D to 2D. Analysis type. 3D to 2D. Then you double click. Once it will open, we are opening geometry. Means we are opening design model. Unit will be fixed. Let it be unit as the minimum. So this is the case. By default meter, I want to change unit to millimeter. Which axis you want? X, Y, Y, Z or Z, X? Which plane? X, Y. So here X, Y. Use case. See from the top, come here. So I want to create the circle. Let it be instead of circle, I want to create ellipse itself. I will create ellipse, semi-major axis, semi-minor axis. When it is same, it will represent
Circle.
single shot. It will parametric study will do. So I want ellipse. I want to create ellipse. To create ellipse, click or press or hold center of the ellipse. So this is the center P constant. Then click or release for end point of one ellipse axis. This C constant. Then click to indicate length of the other axis. So ellipse has been created. Where center is changed. Semi-major axis, semi-minor axis I have not given till now. I have created the ellipse. Now dimensions. Very good. Dimensions. So if I click like this, one is say length or distance. let me change this, and if I select this, then I can get this one dimension. Similar way, but given this to this, right? So then this to this. Wait, something else. Oh, that has moved, so undo it. This length or distance. So select this and this to give this. Let it be. Let me check. Some exercise I have done. So here radius was r, correct? So 10 mm. We'll do parameterization later on, no problem. 10 mm. So this to this distance I have taken. Now I have to do this to this distance. Is not it? Let it be this is also 10 mm. That means it is now representing circle. But I have taken a ellipse. I can do parameterizations for this two answer. Two lengths. Then next is draw one rectangle. Let it be this is the rectangle. Okay. I want this rectangle should be symmetric with respect to the axis. So go to constraint symmetry. Select this one. Select line for axis of symmetry. Then left one and right one. So I got it is symmetric with respect to y axis. Now similar way to get symmetry with respect to x axis, center this and this. So this is symmetric with respect to both and x and y axis. Now let me give the dimensions. So this length was 40 entire. So what we will do? This dimension is 40, and let it be. This dimension is this dimension may be 100 because it is not it is almost independent. This is not varying with this length. We will apply the load in the order. Now, for this, it is saying that it is not infinite plane. Now create the surface. Create surface from the space. Apply. Generate. See, it has created this.
Sir, you wouldn't be providing thickness.
Okay. Thickness, whether you are providing or not, it will not enter here because it is 2D. You give no problem. It will be same, no issue. Because finally you will provide the thickness in that analysis part. When we will go to the analysis, we will do that. The question is definitely not. It is not for the case of infinite plane. So all dimensions will be followed by this. So actually we are taking this only. 40 length is 40. Length is not being used basically. This length. So I have taken a little bit more. So now next question is here. Thickness is 1. Now what I am to do? This one is represented symmetric with respect to x and y axis. So we use symmetry. Both axis symmetry. First axis is xz or zx, and this is yz. Generate. So it has created 1/4 of the model. That boundary condition will be imposed to the model already. So zoom to fit is this. Now save it. Now that geometry will be utilized for the analysis. So we will go here. We want to pick here. Static structural analysis. Simple analysis. I want you to utilize this geometry. I want to share this. So that geometry has been shared here. Or maybe directly static structural analysis I can do. What can I can create? Or maybe you can import the geometry from other software like ADR, SolidWorks. Now open the model. Now it is opening mechanical. Starting mechanical. Till now we are on the phase to create the geometry part of the design model. Not this mechanical or CSM lab. That is the part of other CAD lab. Now we got geometry here. Let me check. As I told, by default it is structural steel. See, this is the surface body. Thickness is 1 mm. I can change if I want 5 mm or anything is we can do. Let it be 1 mm. Parameterization will do that. Now, one thing you can see, if I select here, it is showing plane space. Now, if somebody is interested for other case, somebody can give this plane space, axis symmetry. There is another concept, generalized plane space, little bit complex, leave it. There will be 2D analysis in 3 types: plane space, axisymmetric, and plane strain. We are here for the plane space. By default, it is plane space. Now, you can see this two symmetry boundary conditions already imposed. Now, let's have generate the mesh. It is by default mesh. Here I am getting the mesh. Maybe your version is supposed to get better quality of mesh. But I am not getting good quality of mesh because it's old version. Your version, if you click there, mesh, better quality mesh will get. Anyway, I am doing some sort of modification, say map face meshing. Let me check if it works.
मैप फेस मशीन का
I should save it. It is not, it is failed because due to the geometry. Leave it. First of all, let me size. Oh, let me size to get the size. What is this length of this model? We can get from this one information. If you click this, it is showing not area, line. This length is 50. Maybe we want 100 divisions. 5 mm. Let me check. 5 mm mesh size, global mesh size. Sizing. Not less. I want full body. Entire body. Mesh size I want element size maybe 5 mm. Generate. Wait. Now we start giving some error because once again let me check. This length is delete this error. Not error, warning. So, what is this length? This length size is. We are planning to have good quality of mesh. This is 40 mm, this is 50 mm. And here I told body sizing was 5 mm. 2 mm. This looks better, correct? 2 mm, maybe 1 mm. Or other way I can give insert sizing. Maybe here number of divisions I want. Maybe 16. This is different way we can do the improvement of the mesh. Maybe like this. Maybe this 16, maybe 32. No, 24. this size may be 1.5 mm. Let it be. We are assuming this is so. Whatever change I did, no mesh size, different mesh size. They are study for mesh sensitivity study. So after doing all the iterations, say 5 or 6 set of results I can show, and its effect of the KT value changing. What is the change of the KT value? I can understand. Of that mesh sensitivity study, that you have to show at least 5 cases of the different mesh size solutions. Now I have to apply say some constant pressure, not pressure basically. This is I want to apply minus 10 MPa pressure means what does it mean? Minus 10 MPa pressure means tensile. I want tensile. Right? That's all. Solve. Let me check the KT value on the KT.
तूने सेंड पहले
So pressure was applied on the right direction.
Huh? No, pressure is not direction. All is perpendicular to the surface. Pressure I have applied perpendicular to the surface. I have taken right size of the yeah. So if I now put this deformations, say total deformations, duplicate directional deformation x-axis, duplicate directional deformations y-axis. Rename based on definitions. Evaluate coordinates. Let me check. So this way, total deformation. This is the x-axis. This is the y-axis. So yeah. So concept-wise it is fine, correct? I have one symmetry in y-axis. In x-axis I have another symmetry, and it is supposed to move in that direction. This is the displacement plot. Now, what about the space? No, now I have told that tangential space, other is axial space. So axial space and tangential is means sigma theta, and that is tangential. We have explained from this one. Say for this case, say I am here. So when it is sigma theta, that one is related to stress concentration. So if I am here or I am here, if I see when I am here, this theta is 90 degree, and I am talking about the stress along the horizontal axis. But when I am here, it is along the vertical axis. You can give answer here later. Insert stress. Now, what type of stress you are looking for? 1/c stress or sigma maximum, sigma minimum, sigma x or sigma y? Which one you want to compare here to get the stress concentration? 1/c stress, sigma x, sigma y, sigma maximum or sigma minimum? Which one do you think that can correlate with the KT or stress concentration product? Tell me. 1/c is valid or not? First of all, KT or stress concentration factor can be correlated with 1/c. Yes or no? If it is yes, why? If it is no, then why? Now tell me, stress concentration is relating to tangential stress, sigma theta. Now sigma theta is related to 1/c or not? 1/c can represent sigma theta, yes or no? What is 1/c stress? Can you recall the expression of the 1/c stress? Third semester stress computation. Is it covered? No. Okay. Anyway, sixth semester I have the exclusive that part for the theories of failure based on the yielding in the subject called aerospace engineering. Sixth semester. Now the students are in that syllabus is included. Tomorrow from 10:50 I have to cover that sixth theory subject. Anyway, now this is correlated to either sigma x or sigma y. Not 1 by 6 days. So if I go not that is sigma x, sigma 1, those are normal states. Say here it is sigma x. Duplicate sigma y. Duplicate sigma x. Rename based on definitions. Evaluate parameters. Now you see this sigma x along this x. Okay. Now here it is compressive. Here it is tensile. So what is the things we are talking sigma maximum? That is sigma x here. Theta 90 degree. 43 MPa. Okay, and here it is the negative. Compressive. I told no tensile force I have applied. This position you will get negative, here you will get positive. Now, to make it more convenient, I want to move this problem to infinite plate. To do the infinite plate, my plan will be so either I can two things I can do. Here this circle can be lower or the dimensions could be bigger. So let it be this ellipse makes here circle maybe as it is. I am changing this. Say 200 and this also 200. Let it be this way. So if I replace geometry here, so 1.5 mm, 24. Let me save it. Generate mesh. Okay, maybe this is the mesh. Not bad. Now solve it. This is analogous to infinite place. So what I am expecting, if I have 10 MPa inside force, then one and vertical top direction is supposed to be 3 times of 10, 30 MPa. And right side here is supposed to be minus 10 MPa. Let me check what value we got. Deformations looks fine. That way it should be from. Yes, deformations. Yes, looks fine. Y deformations. Contour is okay. Now x-axis normal stress. You see, it is 30.8 and it is minus 6 point some value. But which value should correlate with stress concentration factor? This one or this one? Tell me. Stress concentration factor will correlate with value here or value here? I have applied load in along the x direction. Z. So 30.8 almost 3 times. It is infinite. Now I have circle radius is same 10 mm radius, but other dimensions it looks infinite. The ratio, this this radius to this width ratio looks not infinite. I think it is 10 and it is 100, more than 10. So in fact it can be considered as the semi-infinite, close to infinite. That's why it is 3. So I am looking for sigma x. So sigma x is tangential at this location. this is most careful case. Sigma x is at this locations is tangential. Sigma x is the sigma theta, that is tangential for theta 90 degree here. But what about this case? This is not tangential, it is perpendicular to the surface. To get that for value for theta equal to 0, we have to look for sigma y. Here it is negative, it is minus 10.6. We told it is minus sigma. Sigma is the current stage 10 mm. So it is correlating here with minus sigma. Okay. Now what is sigma z? 0. Why sigma z is 0? Can you tell me why sigma z is 0?
Because it is a 2D problem and there is no stress in the
No pressure.
See, problem may be 2D, but 2D does not mean the stress in z direction is 0. For 2D problem in z direction stress will be 0 when it is plane stress. Only when it is plane stress only, that means we have assumed at the beginning it is plane stress. But if it is plane strain, then epsilon z supposed to be 0. If epsilon z, that is 1 by e, in bracket sigma z minus Poisson ratio multiplied by sigma x plus sigma y. That means sigma z equal to Poisson ratio multiplied by sigma x plus sigma y. So for plane strain, although the problem is 2D problem, you can get stresses. First question is why it is 0? Answer only one answer, that is plane stress problem. 2D problem does not mean always z in z direction stress is 0. Because 2D problem can have three types: plane stress, plane strain, and axisymmetry. In axisymmetry also you can see some stress in that direction, z direction. So answer is plane stress. Now I'm back here. So I want to give dimensions like this only. Circular. Now once again I am going back. This is 40 and this is 40. So 3 times I have already shown that 3 times concept, 3 times of KT for infinite plate, circular, 3 times. Now if it is not circular, let it be this problem. This is not circular. So Young's modulus 200 and 0.3 by default structural steel. So let it be length this B. So I am now infinite plate. Now let it be this way. A is 5 and B is 10. A is 5, B is 10. Come here. This is 5. A is 5. No, it's now reverse. As per the figure, A is 5, B is 10. No. This is 10. This is 5. So I am changing here, it is already changing. See, it is now we are getting ellipse. A is 5. This then KT is 5. And sigma max supposed to be 50. Already all formula has been put here. Semi-infinite plate. So different geometry. Mesh it. Generate mesh. Solve it. So what you understood as per these expressions? So not this. These are the values I am putting here. So to make infinite. And A and B ratio I have taken as a 2, B by A ratio. This is B here, this is A, be careful. This is B, this is A, ratio is 2. And KT is 5. So if I apply nominal stress 10 MPa, I am supposed to get 50 MPa maximum stress, and minimum stress also minus 10 MPa. I think it is solved already. Now go to the solutions. This is the deformations. Now here deformation, no stress. See, maximum stress 50.648. That is located here, and minimum is 0.45. Don't be confused. To get stress here, you have to take sigma y. That is minus 10.3. Try to correlate sigma x here. Axial load sigma x. Load is along x axis. So at this point, sigma x will be stress concentration factor. To calculate that is sigma x 50.6, or almost 5 times of 10 MPa load for fixed stress. And to get this look here, it is sigma y. So all sigma x and sigma y, we are talking about one point here, sigma y. This is sigma x. They are tangential, not normal stress. That's why sigma theta is the representation of the KT value or stress concentration. So what we are getting now, what you have to do, you have to take the dimensions. And along the dimensions, let me do another way. I am putting here, and let it be this A and B I am interchanging, or it is 10 and 5. Then KT is 2. I am interchanging. KT is 2. Let me check it. It is 20 point, now it is 20.218. K is 2. Now this is once again minus 10. So compressive was same. Now question is why I have applied the load in these directions. Now when this is ellipse, ellipse is looking like this, stress concentration factor is more. But when I am here like this, stress concentration factor is less. Why? Because this is the effective area giving resistance against the load. Now, if the ellipse is like this, effective area is less. So load path, if I consider load path, imaginary path which is carrying the load from this side to this side, left side to right side, that load path is being disturbed. Because we are in the load path, if there is no circular hole or cutout, load path is always parallel, imaginary line. Now, once I have introduced the notch, or circular hole or elliptical hole, load path is being disturbed near the circular or elliptical hole or cutout. Now, the positions, if I have this way, then more disturbance. This load path is not affected. Now, once this load path are being affected by the existence of the cutout, we can get stress accumulated near some edge of the cutout. That is known as the stress concentration effect. Now, it is a very simple problem that I have load in one direction. Now, let it be. I have applied load in one direction, x directions and y direction both. Or you have one plate, x directions and y direction, both directions you have applied. Now, assume that plate now you want to make as a cylinder, thin cylinder. Now, assume that thin cylinder is nothing but the fuselage of the structures. In the fuselage, due to the human compound, inside is atmospheric pressures. There will be some internal pressure inside, atmospheric pressure. Outside there are many things, correct? Lift, for the formation of the leaf, aerodynamic pressure, gutter, and many gas load. But inside it is always 1 atmosphere pressure. Otherwise, human comfort will not be. You cannot travel that. In that case, it is two forces are being active. Axial force, other is hook force. Axial stress, other is hook stress. Now you know from this third semester, thin plate or shell something, no?
Yes.
For hook stress and axial stress, which one is maximum? Axial stress and hook stress, which one is maximum?
Sir, this communication.
No, that is axial stress. Hook stress was maximum, 2 times of the axial stress. You can recall. Hook stress was 2 times of the axial. If it is so, say this is 100 MPa, and this, sorry, 1 bar, I should say. This is 1 bar, this is a 2 bar, 2 times. So, like 0.1 MPa and 0.2 MPa, roughly, these directions. Then due to the cumulative effect, this one will create 3 sigma, this zone, and here it is minus sigma, due to axial load. 3 sigma and minus sigma. And when I have load these directions, 3 sigma here it is minus sigma. Due to the combination of these 3 sigma and minus sigma, one case sigma is double of the other. It is expected that your windows and doors supposed to be this shape. Otherwise, if it is reversed, this have you seen, no? I think you have seen this. This door is this shape or window is this shape. If you make it this way, then stress constant is supposed to be 4 times more. That is the way they have utilized the concept of superpositions of the stresses due to the biaxial load. One is axial load and other is hook stress. So we are doing that mini part of this real problem. Now once I have changed this, load path variation is less, that's why stress concentration is 2 here. Now till now we are discussing regarding one elliptical hole for infinite plate. Simply we can move to this elliptical hole to circular. Next is finite plate.